is Chen and I'm come from China. It's my great pleasure to be selected for Best Research Award, and I'm very pleased for Science Fellow and Award Manager. My topic today is how to deal with the problem of inconsistent results in observational studies. I'm 29 years old, and I major in clinical medicine, cardiology, and I also have some experience in engineering data process. Now I learned in Zhejiang Chinese Medical University. There are some important research fields in my academic career. I have learned epidemiology study, clinical research, systematic review and meta-analysis, clinical data deeming and machine learning, advanced study combined with material randomization analysis, system review and meta-analysis combined with material randomization analysis, single cell sequence combined with material randomization analysis. In the past 3 years, I have published a lot of articles as the primary author. Now, return to my topic today, how to deal with the problem of inconsistent results in observational studies. In practice, we often see the same type of clinical observational studies, but they are inconsistent results with inconsistent conclusions, especially due to the interference of confounding factors and inadequate adjustment for confounding factors. How to make a appropriate decision from lots of inconsistent evidence is a challenging thing. While we can combine the observational research method and genetic research method to further investigate the relationship among the objectives. This is a very interesting question, such as meta-analysis combining with material randomization analysis. This is a successful case, which our team published in European Journal of Internal Medicine. We use the meta-analysis combined with material randomization analysis to investigate the short sleep duration and artery fibrillation risk. This is the research background. Recently, some observational study reported that short sleep duration increased the risk of developing artery fibrillation. However, some studies did not support this conclusion. How to get a relevant objective conclusion based on previous research results is a problem we often encounter in clinical research. So the first step method, systematic review and meta-analysis. We need to clarify the relationship between short sleep duration and artery fibrillation in observational studies. And then we should collect all the evidence of observational studies and further summarize the result of these observational studies and then use meta-analysis method to calculate the summarized effect value of short sleep duration on artery fibrillation. This is the research process of our article, and we search three major databases and include PubMed, Embase, Cochrane Library, and we collected the relevant research evidence. This is the detail of the characteristic of the included studies, and we make it into a table. We finally included 6 studies, and we conducted a meta-analysis of above research results. And meta-analysis shows that a significant association between short sleep duration and a high risk of developing atrial fibrillation. We can say the rest radio is 1.28, and the p-value has a significant difference. The second step, the association between short sleep duration and atrial fibrillation observed in studies may be causal, but could also be influenced by confronting bias, means that this may be other uh, there may be other factors that influence the result of studies. Therefore, observational studies provide important insights. They cannot establish causality. Therefore, we need to provide a deep genetic examination of this relationship between short sleep and atrial fibrillation. Mendelian randomization can effectively control confounding pairs of observational study, which is a good method to solve this problem. We use summarized statistics for for individuals of short sleep duration from a larger scale Jones database of the UK Biobank. Based on this Jones data, a total of 16 genome-wide SNPs were significantly associated with short sleep duration. We extract information about these 16 short sleep duration associated SNPs from the atrial fibrillation database and summarize the data into a table. As shown in this figure, we can see we use 9 Mendelian randomization analysis method to calculate the final results. The IVW method and the MRX method were the major Mendelian randomization analysis method, and we can see these two methods for all showed no significant causal relationship between short sleep duration and the risk of developing atrial fibrillation. This is the detailed result of 9 material randomization analysis, and we can see all of them have no significant difference. So in the end, the research conclusions that the meta-analysis shows that short sleep duration is associated with a higher risk of atrial fibrillation. However, Mendelian randomization analysis shows that no causal relationship between genetically short sleep and the risk of developing atrial fibrillation. This study method also has application, and that is to solve the problem of inconsistent conclusions in clinical observational studies. That analysis can be used to first to analyze the preliminary studies, preliminary results, and then Mendelian randomization can be used to calculate the causality of heterogeneous leaf, so as to provide a reasonable logic design for the whole set of research. That's all. Thank you for listening.